हेलो एवरीवन। तो यार आज के इस वीडियो में अपन जो है देख रहे हैं मैथ्स के कुछ प्रॉब्लम्स देखेंगे। तो सबसे पहले मैथ में जाता हूँ मैं और अपन थोड़ा सा सिंगिज जी तिवानी अपन देख रहे होंगे। लेवल लगा ना। सो yeah, here it is and you can see this clearly. It's sine 45 minus 30. So if we find sine 15 degrees, then we are going to going to apply the formula of sine A minus sine B. Okay, so that will create our solution. Okay, so now if we see it properly, so you can see that we can prove cos 15 as a root 3 plus 1 by divided by 2 root 2. So this can be easily done with the help of the same formula that we have used for sine of a minus b. We can use sine a cos of a minus b in the same format and we can get the result as this one. So if you remember it, it will be helpful to you. So do try to remember the things that we have. And supposedly if you want to find 18, okay, so if you see, if you multiply 18 in multiplied by some number like 5, then we can say it will be 90 degrees. So we can use this property and try to understand what will be the value of its sine theta, which is theta we are considering as 18 degrees. Okay, so we can similarly follow the procedure. We know sine, we can get this sine 2 theta equals to cos 3 theta and expand the terms. We have already formulated these formulas and we try to understand uh, the things that we have in this kind of a scenario. Next we have this sine theta, which is like sine 18 degrees, which is greater than 18 degrees, which lies in the first quadrant. Okay, so similarly we have this cos 18. You can just remember the value of sine 18 and you can automatically get the value of cos 18 degrees with the help of the identity that we have, which is cos square x, which is nothing but we can use maybe this pen. So cos square theta plus sine square theta equals to 1. So if we know sine theta, then we can easily calculate cos theta as well. So now we can also find the value of 7.5 degrees, cot of 7.5 degrees, which is not much important, but if you want you can do it. Okay, so we can just consider, we know the value of cos 15 and sine 15 degrees, so we can just apply the formula of tan theta, which is considered in 1 minus cos 2 theta, and we know the value of cos 2 theta and sine 2 theta. Then we can easily plug in the values and get the value of tan of 7.5 degrees. Okay, so now we have this table that you can see. In this table we have different values which are not standard, like if we see the standard values, which are 0, 30, 45, 60 and 90. So these all are in degrees. So these are standard values that you need to remember, but see, these some of these might be asked in your JEE Mains examinations. You can always find some exceptional questions where they ask about of a sine of 22.5 degrees. So that's where these things, remembering these things will help you guys. But all we always have the option to derive things. If we just remember how to derive things, we can easily go through the steps, and if we have time we can always find these values. Okay, so now we will move on to the next topic, which is sum of sines or cosines of n angles in AP. So supposedly we have this sine alpha plus sine of alpha plus alpha beta. It should may not be alpha beta, it should be 1 beta. Okay, and here we have sine of alpha plus 2 beta, and so on. We have some kind of AP in the terms of sine. Okay, so how to find these kinds of values using the properties that we already have? So we just consider it to be equal to s. Okay, and the angle which is in AP is a beta, which the common difference is beta. Since you can see that first term is alpha, second is alpha plus beta, third term is alpha plus 2 beta. So you can see that the clear difference between each of these terms is d, which is justified by this assumption that it is the sine of cosines of n angles in the AP. Okay, so now we use one trick over here. And what is that trick? Like, we know that what is sine of alpha, some value of sine of theta 1 into sine of theta 2. So we know how to formulate those things. So we just try to multiply both sides with this and separate those terms in the individual terms. So this is the trick that we are going to apply over here. So we just apply this trick to each and every term of this expression. Like this expression, this, and all of these are replaced by these terms, which are nothing but the separated version. Means you can say that we have split the multiplication into subtraction or addition, whatever you say. So this is the one trick that we have to use, so that the terms you get, you see that things cancel out with each other. So supposedly we add these terms, so these will get cancelled out, and will be left with the first term and the last term that we have, and we can easily find the value of s, which is nothing but the sum of sines of angles, in AP. So finally we can see that if we want to find the value of cos series in AP, so we can do a simple replacement, or we can say the substitution of pi by 2 plus alpha in the expression. Okay, so now we want to find the value of cos of 2 pi over 7, and we want to find the cos of 4 pi by 7, and this. So this term can be easily calculated. If you see that here comes the AP, and you can easily see the AP. So this is 2 pi by 7, 4 pi by 7, 6 pi by 7. So this forms an AP, and we have a standard formula for these kinds of things in our minds as well. So now here we can see this is again a similar question, which is, so instead of just theta being the common difference, we can see that the common difference is 2 theta. So just replace that value by 2 theta in our standard result, and we'll get the solution to this problem, and it will be coming out as sine square of n theta divided by sine of theta. So now we want to see some standard identities which are applicable in triangles. So in triangles we have some properties that are really useful. You will find it in many questions that they use these properties directly, and we when we want to simplify things, we just just remembering these identities can be really helpful and reduce your calculations to a large extent. So this is some identity, and we need to prove this. So it has a proof, but if you remember it for a triangle, tan a plus tan b plus tan c is equals to tan a times tan b times tan c, then it will be really helpful. But yeah, there is always a proof, so we can just see that we can replace a plus b by pi minus c. So we just split the terms, we formulate both the RHS and LHS, and just try to subtract, multiply, divide, everything that you need, and just managing the terms we get this expression. Now similarly we have this kind of a property. So this is sometimes helpful but not always. But okay, we just want to see the formula, the identities that we have, so we can just use them as well. So you can see the proof here. Here is the proof, and we're not going into this, so we'll move ahead. Yeah, this one, this identity is something um, really a great identity. I would say it appears to be very simple, but it is really very deep. So how you see it? So firstly we club the terms, we club the two terms in terms of sine of alpha plus sine of beta, let's say. Okay, and we merge those terms, and then we try to replace the a plus b with pi by c, pi minus c, and then we just apply the common term that we have in both the terms, and take the again the same c and replace it with a plus b. So this step is very crucial. You can see if you don't replace it with a plus b, pi minus a plus b, then you won't be able to get some identity of this type. But here we have to apply this that knowledge, that trick, you can say, and we can see that this kind of equations we can get. Okay, so now we have this cos of 2a plus cos of 2b plus cos of 2c, which is equals to minus 1 minus 4 cos a cos b cos c. So now we just club in the terms, we just try to solve the problems to cos c minus. So we just know that what is cos 2 theta. We all know that cos 2 theta is equals to cos square theta minus 1. So we know that this can be easily done with the help of like cos square 2 theta is nothing but, so we have cos 2 theta, so it is not square, it is cos 2 theta. Cos 2 theta is nothing but cos square theta minus sin square theta. So if we just replace cos square theta, and this term is replaced by, we know that once cos square plus sin square is 1, so that's why we can say that it is nothing but 1 minus cos square theta. So we just replace this and we get the value as 2 cos square theta minus 1. This is what we get. So next we have some formulas again, so you can just go through and see. If you don't understand, please ask me if you don't understand any of the steps, and we will move ahead. Okay, so we have some important results. Yeah, these results are very important. Like these are sometimes asked directly in the JEE Mains examination, and we just need to know the common the difference between the terms. So you can see that it is a, then 16 minus a, then 16 plus a. So you can clearly see that there is some sort of pattern over here. So like we have this LHS, we take the LHS side, and we try to club these two terms, because we can see that clearly. We know that is cos of a minus b times the cos of b minus a minus b, and a plus b cos of. So we just club in the terms and we get this value, because we know cos of a plus b times cos of a minus b is always going to be equal to cos square a minus sine square b. So this is the identity that we are using over here, and since we know the value of cos square 60, we just replace it by 1 by 2 and square it, which becomes 1 by 4, and then just multiply the terms inside the equation that we have. So we just club in the terms and we just replace this sine square a with the help of the identity that we have, c square plus cos square sine square plus cos square equals to 1. So we have this term, and then we replace this term, and subtraction and addition, all that you need, and just multiply this cosine term inside, and you can see a beautiful identity that we have, which is nothing but cos of 3 theta equals to 4 times cos cube theta minus 3 cos theta. So this is is a well known identity. So we can just replace this term with this and get the RHS that we wanted. Okay, similarly we have this kind of situation, so you just can remember this directly. We will move on to the next topic. Yeah, so these are some of the important inequalities that we see. These are sometimes really helpful. So these are some of the your objective questions. You can solve all of them, and if you find any doubt or something, you can always ask me these things, and you can write to me, you can message me on Telegram. I will try to solve your problems and give it to you guys. If you don't understand with the help of this textbook, you can always come on and ask me. Okay, so now we'll move on further for some more kinds of problems that we are going to solve. So here you can see this problem. This is a really good problem. You can use you'll be using a lot of not that much of identities, but yeah, that the basics that we have, the sine of alpha plus beta is what, sine of cos of alpha plus beta is what, tan of alpha plus beta. So if you know those formulas, you can solve these kinds of problems as well. Okay, so yeah, we move on to the next chapter that we have. So we'll move on to the next chapter. These are the solution to the problems. Okay, and these are some of the objective type solutions and all these things we have. So I'm just scrolling it down to get the page that we want. Yeah, so here we go. The chapter 3, trigonometric equations. We'll see the trigonometric equation, general solutions of some standard equations, problems based on extreme values of a function. We'll see the inequalities as well. So, like, what are trigonometric equation? So, the any equation you see, any equation involving one or more trigonometrical ratios of some unknown angles, and that is a trigonometric equation. Just take an example. So here we have some example. So you can see this. There are some unknowns and there are some trigonometrical ratios which are like cos x and sin x over here. So this forms a trigonometric equation. Okay. So now we have something called a solution or root of a trigonometrical equation. So if we see any trigonometric equation, there could be some solution to that problem. So if we just see, like, supposedly we have this sine square theta plus cos square theta equals to 2. If I ask you what is the value of theta, so you'll say that cos sine square theta and cos square theta, they are always going to be equal to 1, but 2 is not equal to 1. So this situation is not possible. It is not possible. So we can say that this equation has no solution. So I'm telling you the extremities. The one extreme is there is no solution, and the other extreme is there is infinite number of solutions. So just consider this example again, and if you see, like, if I give you sine square theta plus cos square theta equals to 1, then we know that this equation has infinite number of solutions, because we know that whatever is the value of theta, whatever may be the value of theta, you are always going to get no. So this value is always going to be equal to 1. Okay, so now there is something called as principal solution. So what is principal solution? So we just see that if you see this, so if you see, I would say by just this example we'll be able to understand what is trigonometric equation, what is the solution or root of trigonometric equation, what is a principal solution, what is something called a general solution. So with just this we'll be able to understand this. So bear with me and go with me. So see how would you understand these things. So let me just erase this and get you through these things again. So yeah, so like we have this sine square theta x, so you want whatever you want. So like I would say sine square theta plus cos square theta equals to 1. Okay, so you see that what will be the solution of this problem. So let's say theta belongs to any real number, this will be the solution to this. Okay, like it should be in radians, you see. So if you see, if I were to say that if this equation has solution some x is a solution. Okay, so if I were to say 2 pi plus x, then also this equation, this is the solution of this equation. If I say 4 pi plus x, then also it will be the solution. So we can clearly see that if x lies between 0 and 2 pi, then only the solution will be the principal solution. And the other solution that are going beyond this limit, we say that this kind of a solution is the general solution of the trigonometric equation that we have. Okay, so now if you see sine theta equals to 0, you can see the theta values are always going to be n pi, where n belongs to integer. So this is something that you need to remember. You see, if you were to see the graph of sine theta, you can easily see that when is sine theta equals to 0. Sine theta is equals to 0 only when the values of theta are n pi, where n is the integer. So the solution could be 1 pi, 2 pi, 3 pi, 6 pi, whatever you say, 100 pi, 1 lakh pi. So all the things will be the solution. And what are the number of solutions to this problem, if I were to say that? So you will be able to answer that like, okay, what will be the number solution? Like, it will be infinite. But if I were to ask you what are the principal solutions of this equation, so then there comes a condition that the theta must lie between 2 pi and 0. Okay, equality holds. So in that situation, we can only take the solution as 0, pi and 2 pi. So you see, this is 0 into pi, this is 1 into pi, this is 2 into pi. These are integers, you see. So this is the principal range of the solution. In a similar fashion, we can say that cos theta equals to 0, then theta will be odd multiple of pi by 2, where n is integer. You can see it from graph. Similarly, for tan theta we have this kind of a thing. And similarly, we also have similar type of a solution, which is general solution. So this is a general solution, if you see. But if I were to ask you what is the principal solution, that you must restrict yourself between the range 0 to 2 pi, so that you can get the principal solution. In a similar way, if I were to say sine theta equals to -1, then we have this kind of a equation. And similarly for cos thetas, and we have these kinds of solutions. So these are something that you can remember if you are someone who want to solve the problems very quickly. So you can remember these things. So these are not that much of a burden. So we have these kinds of problems like sine theta, sine x plus cos x is equals to 1. So we use some squaring, and then we try to find out the general solution of the problems. And we can also report the that kind of your the solution of the problem in a general sense as well. And we have these kinds of problems, so we'll see these problems as well. So here you see this one is a good problem. So if you see that we replace the sine powers 16 power sine x square sine square x, then we can easily form a quadratic equation and find the solutions to the problem, and then find the principal solutions that lie in the range. So since the x is varying from 0 to pi, so we have to report the principal solutions only. So here we have the solutions to this problem. So in total we have 4 plus 4, 8 solutions in all. Okay,